Hi ladies and gentlemen, how you doing? This video is about fault analysis in three-phase systems, and in this video I will try to demonstrate each and every block step by step. But the thing is that it's not a kind of very practical simulation, just a little bit of theoretical simulation, and we are just using a simulate to do this. So all the blocks which are used in this simulation or this model is from uh, sim power system library. And suppose if you want to just choose a three-phase source, then you have to go to sim power system, and it's just electrical sources, and here it is. And if you want to just use this block three-phase vi measurements, then it is over here. Here is this measurements, and here is a three-phase vi measurements block. Let's just get started from here, our source, which is three-phase source, and the parameters are that we are using 11 kV kilovolts, which is our RMS value, and we are just not changing the angles and just doing a frequency. Base voltages are also the same, which are RMS voltages. Next thing is we are using a circuit breaker, which is three-phase. The thing is that it have three inputs and four inputs and three outputs. The three inputs are just coming from three-phase source, and the circuit breaker is actuated by some kind of external mechanism, which is a relay. So we have fourth link is from relay. So the thing is that initial status the circuit breaker is closed, yes it should be, and then I haven't changed all of the other parameters. And the most important thing over here is the switching time, so I'm just controlling the switching time of this circuit breaker by some external source, which is obviously a relay, which is here. Next step is we are just doing a measurements, because we have to calculate how much excessive current is passing through the system when a fault occurs. So it has three inputs, and it has also three outputs, because the input is going same to the load, but we have to measure the VA voltages and current. And current measurements, yes, face to face we are using, and just okay. So here we are using demux, which has one input and three outputs. So you can change the number of outputs from here of a demux, and this is our three-phase load, and nominal phase to phase voltages are 11 kV, frequency is 50, and active power is this, and inductive power is this. Load flow is the load type is constant Z. Next, the most important thing is that we have a three-phase fault, which will be induced in this circuit over here. So before load, and this three-phase fault will occur at when this step functions actuates this fault mechanism, and we are just have a step of 0.1. So when the time will be 0.1, a pulse will be generated from step functions, and it enters the three-phase, and the fault will occur. So initial value is always 0, and final value is also always 1. Now we are just using scopes to see the voltages and current, and then the most important thing, which is our relay. So it is a kind of subsystem which has three inputs and one output. So here's our relay. So it's a kind of theoretical relay, not practical, because I don't think so any SR flip-flops are being used in kind of relays, but they can be used in simulations. So here we are just trying to compare our input voltages, input current, and when it's cross a certain limit, for example 30 into 10 raised to the power 3, 30 kiloamperes, then this comparison will be done. So to compare two values, we have to use this block. So it's kind of rational operator. When you're gonna choose this operator, you're gonna choose thing greater than, because we have a lot of options, and that type will be boolean, because we are just taking input in the terms of binary here. And after doing this comparison, we are just giving this output to the SR flip-flop, and the thing is that R of port of this flip-flop is just connected to the constant, and the output of this comparison rational operator is going to the S block, and we are not using this Q output, so we used a terminator, and then the Q dash is just used. Now here we are just using an AND gate, a logical operator. The thing is that it has a number of three. It has a number of three inputs, and the thing is that if all of these values are one or the same, then the AND gate will give one. And as the output of this AND gate is digital, so we're gonna just convert it from digital to double. So it's a data conversion, and you can just change it from here. So here's double, and after that, here over output, the output is going from here to this circuit breaker. So as the fault occurs, the relay senses compares when the current is exceeding to the safe limit, which is and then this circle actuates. The most important thing is that I'm using this running simulation for 0.3 seconds, and the fault will occur at 0.1 seconds. So let's run the simulation. The simulation has been run is 26%. We're gonna check the output from these scopes. So first of all, we'll just check the scope output of this. So the thing is that the current was flowing normally, as you can see over here, which is around about 1 into 10 raised to the power maybe 4 amps. Now when the fall occurs at 0.1, which is our step functions when get actuated at 0.1, the fall is induced into this circuit. So what happens? At the same time, a huge amount of current flows into the circuit, which is around about 6 into 10 raised to the power 4, which is more than the comparison value over here. So we are just comparing that amount of current to this. So as the current is exceeding 10 raised to the power 4, the relay is actuated, and as you can see, the voltage is, or the current is now 0 up to the second 0.3 second of simulation. So you might also have observed that the fall is occur at here, and still it's increasing, and then the relay haven't stopped the current unless it don't it touches the 0 value. So the relay is operating until unless the value is zeroed, and you have to almost complete the circle until unless it reaches to the reference value of 0 ampere. So that was our current, and if you click this, you can have just 3 phase voltages. So as you can see, just voltages are flowing, but as the fall is occur at 0.1, as you can see over here, when a short circuit happens, a lot of current is produced and the voltage almost approaches 0. So at the same time, as you can see, the voltage is approaching 0 very rapidly over here. The thing is that you can just make 3 output. You can make the scope to take 3 input from here. Number of axes are 3, and that's it. So that was our simulation, but the thing is that it's not kind of very practical, but it is theoretical. The file will be in the description that you can just download it. Have a good day. Take care. Bye.